Alright, I'm Bill Woods. I'd like to talk to you about an approach used to adjust the accuracy of the angle on the cross sled for your saw. Normally use the 5-cut method for setting up the wedges or cutting the wedges that are used to make the measurements to determine how much to move the fence in one direction or the other. This was cut out of a perfectly rectangular piece, if you will. First cut was used just to check the accuracy of the angle. This would normally be your first cut on the wedge. That's the first wedge to drop off. You can see that the error, there's 1 times the error embodied in that piece. There are 2 times the error embodied in this piece, 3 times, and 4 times. If it was a perfectly good rectangle, the 5th wedge and the 4th wedge are identical. Alright? The 4th wedge is only inaccurate if you start out with a non-rectangular piece. The 5th wedge, the 6th wedge, 7th wedge, and so on are all identical. That's because this is the 5th cut and you made 4 errors. So there are 5 errors. Take away 1 error for the first cut to generate now 4 errors embodied in that. The next one would be 6 errors. Take away 2 errors for, again, 4 bodies or 4 errors embodied in that. These were generated by using this wedge against this fence that was set correctly. The 5-step process has the ability to cut those wedges out of any piece of material, whether it's a rectangle or not. Because the first time you establish a datum, and then the others are cut from that. The 5th cut then gives you the wedge that you measure to set the fence. I'm going to show you the process that we use to set this on. I'll talk a little bit about the actual slide itself first. To be able to clamp, I basically have a threaded bolt with a counterboard nut on the bottom side of the sled and a counterboard on the top of the fence. In between those 2 counterboards, just shy of the top counterboard, it's again hollowed out to give me total liberty, if you will, on the movement of that fence. This side, at the center of rotation, or the pivot point, is actually pressed in down into the fence and pressed into the slide itself. I'll talk a little bit about how you find the center line of that pivot. When this guy's loose and you rotate it in the vertical parallel to the cut line, and we'll call the cut line vertical. When you rotate it vertical, you can draw a line either side of the fence itself. You can rotate that downward, if you will, toward the cut side and put a line either side of the fence. Then you can basically either divide it with a ruler, or you can construct or bisect that geometry to now find the true center of rotation for that pivot. You can see there's a little offset from center. Actually, the closer that pin is to the face of the fence itself, the easier it is for you to set up because of the rotation and the change in the elevation of that fence as you rotate. Well, the angles that we're talking about for adjustment purposes, the angle of movement is so small that that's somewhat irrelevant. The other point that is brought up in the websites a lot is what you use to adjust it. In my case, I decided to throw a little steel into the adjustment, and basically whatever wedge we come up with, I then put the ruler into it, and using this piece, which is basically a dowel pin captured into a piece of plyboard, and a thumb screw that allows me to adjust it from the top. I find that when you try to clamp it from the side, you end up fumbling with it a lot. Pause. Okay, using the 5-cut process, this wedge was generated as the last cut. In other words, this is the 5th cut. Normally what you would do is you'd take the micrometers and you would measure at this end, take the difference, go through the calculations, and then figure out what size shim you had to put over here to now move this fence down to get it parallel. When this taper jig closes up parallel, it will then be parallel to the fence, which the fence is accurate. When this is cut off, it is rotated down, this being the 5th cut, this being the edge that was the original datum. All right, that datum gets turned down against the fence in all cuts. Whether you cut clockwise from this side, counterclockwise from this side, whether your pivot is on the right side or your pivot is on the left side, you always rotate that datum edge to the fence. You also, for this adjustment purposes, always move this wedge away from the pivot end. In other words, I know that that's 17 inches long when it was set. This being the pivot of the taper gauge, this was set, it's set at 17. So now, if I move to this, which is my adjustment point, since this is 17 inches, you work in 4s here. There were 4 cuts. It embodies 4 times the area. You want to move along this tapered element for 1/4 the distance of the length of the fence. This fence is 17 inches long, so you'll move 4 1/4 inches. I could have used 16, but that would have made it too easy. So now you loosen your fence and you're ready to rotate. So you move from the position that you had to the now position 4 1/4 inches away, and sure enough, I'm wedged in between the taper gauge and my stop pin. So that's the adjustment. So now that we've gone through it and showed how it works, we're going to do it in real life. Pause. Alright, we've offset this fence roughly 1/8 up, which basically takes this rectangular block, and as you see, it's not in line with the saw curve. Alright. Now we're basically going to use this as the piece to now realign this fence to the home position. We're not going to make any measurements, if you will. We're simply going to use the 1/4 element and reset that. All right, and we're going to run the blade here. Okay, that's cut number 1. That is the datum, if you will, that we're going to use to line with. Now, plyboard is bad to create fuzz, so I'll rub these guys as we go to get rid of that. So that's the wedge we're going to use. And I've got a little witness stick here that basically has 4 1/4 on it. I'm going to establish 4 1/4 inches on the wedge. Pause. Okay, a couple of things I need to point out. This is a 17-inch mark. 3/16 from there, I've generated another mark. Rather than have people get anal over whether or not this 3/8 inch pin is properly aligned to that center, I set it up so that you can take a square at the 3/16 point. You're now working off of the edge of the pin, and you know that the center of the pin is at 17 inches. Although, frankly, eyeballing it is really close enough. I've got my wedge in there now. And you can tell by the geometry of the wedge that it's going to have to go back down. Remember, we rotate the first curly edge into the fence, and we will move away from the pivot point, always. I'm going to use the 3/16 mark, lock the edge down. Move that out of the way. Loosen the fence. Now move it to the 4 1/4 mark and snug the fence back up against it. I'm going to basically use this now to check for square. We're going to go through that same 5-foot process and measure the difference of the two ends of the final piece, all right? This measures the same at the top as it does on the bottom. We're good. And I'm at 214. And I'm at 214. Time to put the screws in.